Oh, hey there. Just the final chapter of CCNA2 coming up, chapter 11. Alright, so what is the final chapter? Well, we've heard about it before probably. It's called Network Address Translation. And it is what lets us use private addresses on the inside of our network and then translate them to a public address for so we can get on the internet. Okay, so after this chapter, we're going to describe NAT characteristics, describe the benefits and drawbacks of NAT, configure static NAT using the CLI, configure dynamic NAT using the CLI, configure PAT using the CLI, configure port forwarding using the CLI, configure NAT PT, which is version 6 to version 4, which I don't think we're actually going to configure that because it's kind of a rare thing. Anyways, but use the show commands to verify NAT. Alright, so I'm going to jump right in. Why do we need NAT? Well, what NAT's going to do for us is it's going to save addresses because yeah, we have our home network right here, and then go to our little cable router, right? And so this is a private network, and then it gets translated in this router. And so remember, as encapsulation happens, the layer 3 addresses didn't change. Well, with NAT, the layer 3 source changes when it hits this router, and so it thinks the source is right here, and we don't need to know what's behind the iron curtain over here because we've made it to the cloud or the internet or wherever we're going. So yeah, hopefully you guys, I'm not going to go over this much. We have private addresses. Hopefully you remember Class A, Class B, and Class C. Had a whole chapter about that, CCNA1, been talking about them since. So as I said, this is a better drawing of what I just drew. We have a NAT router that keeps the private addresses on one side and the public on the other. So what is it again? Well, let's see. This NAT-enabled router is going to, so this is the ISP, right? And so we're going to translate right here on this interface. It's going to translate. So that another thing NAT allows us is all of this is translated into a directly connected network, so we don't need a routing protocol to this ISP. So we could have as much as we want back here because the ISP still knows how to get here because it thinks everything's coming off of this interface right here. And so it takes the internet, it takes it back, does all this super fun stuff, and keeps this private network working. And so this is how every home works, is they have a device doing that, and this is how most networks work, period. Okay, so this is the worst part about NAT, is these terms. So we have an inside local, right? So there is this inside local bunch of networks, the inside network. Then we have the outside local, and so in this drawing, probably the outside local is the same as the, no, it's not. It's the outside local is the same as the outside global, and then it lives in the network of, well, it's not giving us router addresses, but anyways, so this inside local is trying to get to here. So this is the outside global. Usually our outside local is this. Oh, it is. Okay, I just read those numbers wrong. They're just partially wrong. So this is our outside local interface right there. And then we have our inside global network, right? So this thing, this network. Then we're trying to get to our outside global address, which is this web server or Google or whatever we want to say. So hopefully that sums them up. These are easy to understand when you use the show commands. The show commands, it tells you exactly what they are, and so it's almost easier for you to do that. But try to gain an understanding on these slides. So Cisco's definition: the address of the device which is being translated by NAT. Okay, so it could be this device, or it could be anything in this inside network. The outside address, the address of the destination device. Okay, so here's our outside address. Our local address is a local address that appears on the inside portion of the network. Okay, so I agree with that, except for this outside local is not really appearing on the inside of the network. The local is just on this router. So one side of the router is attached to the local inside network. One side is attached to the outside local network. So we have an outside local interface and an inside local device, right? And then we have an inside global, this is the global network. So we have the global address, which is where we connect to our ISP, and then we have the outside global address that we're going to, which is outside of anything we control, and like Google or the web server. So hopefully that makes some sense to you guys. Here we go. If that didn't make sense, hopefully you can go over this, and it shows you what's going on, right? It's exactly what I just was talking about there with my arrows. So maybe Cisco can make a little more sense of it for you. So go ahead and read that if you're not grasping these terms. So how NAT works. Well, how NAT works is changes the source layer 3 IP on this router. So right there, so it was a public address or a private address, and right there changed to the inside, the outside local. Right, well, let's watch it one more time. I want to see what it changed it to. 192.10.10.2, what does it change it to? 226, yep. So it changed it to that inside global. Alright, so because it doesn't necessarily have to change it to what this interface is. That's the cool thing about NAT, is it can assign a different address. Like if we have a group of public, we can change it to a different address, but we could just change it to what this address is. So I would say this outside local is this interface, but we changed it to an inside global that we have registered to us, which is in the same network as this link right here, right? We could have a few registered to us. Alright, so that's how that's going. Now we have our types of NAT. So static NAT, a one-to-one translation used for a server. Okay, so what that means when we do static NAT, it has one IP address that says, hey, if you're trying to get to this public IP address, whoop, send it up to here. So this is what we do with servers. We use statically NAT servers, or stuff that needs to be accessed from the internet, typically. Okay. Then we have dynamic address translation, which is many to many. It could be many to one. But anyways, so many devices come to this router, and they get translated into either several, actually not many to one, so this is many to many, dynamic, so we would have to have multiple public addresses available, and it could translate all these devices coming to this router into different ones, randomly different ones. Then we have port address translation, right? So port address translations where we do one to many, or many to, we could do many to many on here too. Like if we had 250 devices here. We only had access to 5 addresses. We could do dynamic pat, right? So we translate 5 different connections here to 250 devices, but we're still using port address translation as well. Okay, but what port address translation does is it just does a different port mapping for each device. Instead of just changing the source, it changes them all to the same address, such as, I don't know, 209.165.200.226, but then it uses a port number here, so when it comes back, it's not coming back to a unique address, it's just coming back to an address with a unique port. And this is how most home devices are used. Okay, so static NAT, one-to-one mapping, local and global addresses. These mappings are configured by the network administrator and remain constant. Then dynamic NAT. Dynamic NAT uses a pool of public addresses and assigns them on the first come first served basis, right? So as you can see over here, it's going to assign many addresses to, like, as these guys go, they can pick up a different address. Then we have port address translation, also known as NAT overloading. So that's important, overloading, because when we program it, we actually know it's doing PAT because we do the overload command. Maps multiple private IP version 4 addresses to a single public IP version 4 address or a few addresses. This is what most home routers do. The ISP assigns one address to the router, and yet several members of the household can simultaneously access the internet. This is the most common form of NAT. Alright, so we'll see how it goes. So what's going to change is they have the same address, but if you notice, they have different what the heck? Here it is. Okay, our inside global that it translates them to, they have different port numbers. And then those port numbers are going to be sent back to them. And so they're both sending to 80, but then 80 will send back, if you guys remember how ports work, right? So it sends back to here, and it's the same way we can run multiple applications from one computer. Basically, that's what PAT is doing, a similar action, right? PAT attempts to revert. Let's see. Next available port. What are they trying to show us here? So the first guy gets the same port, and the next one probably gets a 4445. Yep. Okay, so it tries to keep the ports close. That's basically what we're hearing. Now, why would we do that? Because sometimes when we do firewall rules, we're going to filter, I don't know, stuff we don't think we need. And so if they're close, then we maybe allow them. So comparing NAT to PAT. Straight addresses, port numbers. Or, I did it wrong. These are straight addresses. These are addresses with port numbers. So that's the difference. It's also, I don't know, NAT does have some performance flaws, as we're going to find out. So benefits of NAT: conserves the legally registered addressing scheme, conserves private addresses so we can use them, increases the flexibility of connections to the public network for the same reason as the first one, provides consistency for the internet network addressing schemes, and provides network security, because if your device was accessible from the internet without this translation, if you just go straight to a device, well, it leaves a lot more doors open than when you're just getting an IP address with a port or a new IP address that's public. It doesn't know exactly what your network scheme on the other side is, so it provides a layer of security. So here's the disadvantages now. Performance is degraded. Why? Because if we have, whenever we're sharing a connection, right, we're not going to get the full thing, because this is, if we have 2 coming off a NAT, it's going to go down. I mean, we're getting less speed. Each time we do NAT, we're getting a little less speed, more devices we put on there. Also, it's going to take up the CPU, some CPU power of this router, so it's not using it just to route, it's also using it to do NAT, right? And then functionality is degraded. We have to enable, it makes it harder to connect to a device. That's why it makes it more secure. End-to-end IP traceability is lost. Well, that's not always true. I kind of disagree with that. A trace route still, as long as we have a layer 3 on the other side, I guess we wouldn't be seeing it completely, but yeah, it is. I guess we're not seeing exactly where it's going, but what network it's hitting. Tunneling becomes more complicated because, yeah, tunneling becomes more complicated because when we tunnel, we're saying, like, hey, this is the source, and it goes to here, and throw an extra layer 3 on. So then what if we NAT here? I don't know. It's going to take better documentation. Initiating TCP connections can be disrupted. A lot of times when we start up NAT, it works really well after we get it started up, but sometimes it takes a few minutes, in my experience, to actually get it running, and so it can be a little frustrating at first. But anyhow, how do we configure it? Static NAT, the easiest of the NAT. And here's some stuff from a different one, but we'll just go new, and I'll do that for a second. So, static NAT, remember we're just saying, hey, an IP address is going to be mapped to the private. So this computer is going to say, I want to go here. It's going to hit this interface, and this interface maps it and says, hey, you go here. Okay, so the first thing we have to do on all forms of NAT, and it's not the first thing, it's usually the last thing to do, but we go in the interface and we say, one interface is going to be an incoming and one is going to be out. So, or not inside and outside, right? And that's where those terms came in. So we say IP inside the interface, IP NAT inside. Okay, so where we would put that is, it would actually be 0, right here. This is the inside network, so we want to assign that to be an inside, and we usually don't do that first, but this is the one thing that is consistent, so I'm going to say we're doing it first. Then we say interface S00/1 IP NAT outside. Okay, so that's the first thing. If we don't, a lot of times we do the rest of this programming and this configuration, and it does not work because we forgot to say, hey, this is the inside, where this is where what's going to get translated, and this is what is getting translated to, right? So after we configure this, we still need to put those on. That's why we usually do it last, but we're doing it first. Okay. So then, in our picture, you guys can look at that command. I'm just going to do it right here. We say IP NAT inside. I'll look at the syntax, make sure I'm doing it right. IP NAT inside. I don't remember if we do source. Oh, we do. Source. So we do that both, but instead of IP NAT inside source, we say static. And then I believe we do the local IP. So we do 192.168. So this is the inside part of the network. So what was in our picture? This web server, right? That's the public one, and it's 10.192.168.10.254. Okay. And then we say, I believe, outside, and we are going to outside it to 209.165.201.5, right? So this address, and so that that's an enter. This is from global config, right? So it's from global config. The other stuff was from conf if. And that's all there is to static net. It's the easiest one. So let's make sure I did my syntax right. pnet inside source static. Oh, we don't put outside. I guess it's just, we just put the next, what we're going to map it to. So first one, the inside. Second one, the outside. And that's it, besides putting the inside and outside. So static net, the easy one. Go ahead and give it a try. Then analyzing static net. I don't know what they want here, but we're not going to worry about it. Oh, I guess we can use our show command. So this is the one we're going to be using for everything. Show IPNet translations, and static net's easy because it's just always going to be the inside global to the inside local, always going to be the same, unless you did it wrong, then it would be bad. If you wanted to clear your net translations, you can do this clear IPNet statistics. I don't know why you would do this for static net. That's more like dynamic net. Anyways, that's show IPNet statistics. Where do they have that one? That one's, once again, it's going to show you your dynamic and your static nets. It's less useful to me. I don't know. If I guess you're really having problems, you want to see if it's doing anything, you can go there. But I usually use show IPNet translations if I'm having any problems. All right. So our dynamic net. So now we're gonna map many, and so it gets a little more complicated. All right. So this part stays the same, where we assign inside and outside interfaces. Okay. And the start of it, it could start the same here, but usually we start with in the global config, and we say IPNet pool. And what this pool is, I better make sure I'm doing it right, but what the pool is what the multiple addresses that we're going to configure it for. Okay, so IPNet pool, we could do a name, I don't know, I'd say if it was for VLAN 1, I don't know, we go VLAN 1, so it's whatever name you want. You could say NAT1, I don't know, NAT VLAN 1, hey, it's your network, make it how you want. And then we put the start IP and the end IP. So it'd be like, we'll go, maybe for Google, we'd say 8.8.8 to 8.8.8.20. So that would give us 12, and Google has a lot more than that, and that's probably, I don't know, I know they have 8.8.8.8 and 8.8.4.4, so who knows what they have in between there. Then we say, so that's the first part, but then we have to put a mask on because we can translate it into multiple things, right? So we don't have a picture, but anyway, here's our picture. We want that this is our outside network in this pool that we're making. So in our outside pool, we say netmask, which is a weird command. Netmask, and I don't know what the heck the 8.8 is, so we'll just say 255.0. Okay, so that's the prefix that it's going to have on there. And we can use the prefix, but I tell you not to because it is not supported by packet tracer. Okay, so that's the first thing we do. We make that pool. The second thing we do is make a standard ACL, which we can do with just a numbered one. IP, so we'd still be in config. If we want to make a named one, then we can do a named one, but this is going to be standard ACL. So I just say access list 1, and if I wanted to translate, what network are we allowing? The 192.168.11. So I'm going to say access 1, access list 1, permit 192.168.11.0. Okay, so this was our static one. So now we're going to change it. Now we have to link the access list to the pool so that it will dynamically assign. So we say IPNAT inside source list 1, and so where the 1 is right here, right? So it comes from the access list. So we say IP access list 1, or no, IP inside source list 1 pool, and I named my pool VLAN 1. So whatever you named it, you say VLAN 1. So that's linking the list to the pool. Then we put, if we have our IP inside and outside, then our NAT's going to work, right? It's going to start translating it. It will translate addresses as they come from 8 to 20. So we can have 12 devices on the internet with that, with just straight dynamic. Okay. Analyzing it, same deal. Okay. Same show commands, show IPNAT, translations. We're going to have more translations with that. And then show IPNAT statistics, same deal. So then we come to PAT. And so we can actually do PAT, like if we're doing multiple, say we want to do all 255. Oh, and one thing, this access list actually was bad. I didn't finish it with a wildcard mask. Maybe somebody caught that. So it wouldn't have worked at all. And it wouldn't even let me finish that command. But so I need a wildcard mask on there. But say we want all 255 hosts of this network to be translated. Well, we only have 12 addresses here. So what we do on our pool, or what we do on our command down here, is we type overload. And so then it's going to start doing dynamic NAT with port address translation. So dynamic NAT with port address translation means it's going to have those 12, but those 12 are going to be shared among this pool, or among the network we're translating for, and they're going to go into port numbers. There's another way to do this. Instead of, if we just want to go, if we only have one interface, like what's going on in your home network, we keep the same, we can keep the same pool stuff. Actually, we don't need the pool, so I'm just going to delete it. Bam. Okay, so now we still have our access list that tells us what we're going to translate. So the source access, the standard access list, what it's doing is telling us how to translate. But what we do is we take out, so we just put IPNet inside source list 1, and then what we're going to put is interface and then interface number, and I believe on this it was S001. Okay, so what that's going to do, oh, it's 1.0. But what that would do is it would allow us, it would just translate based on this IP address. It would completely just translate on the IP address of that interface, and that's all we have to do. Oh, oops, except it does need the overload command on it. And once we have the overload command, that should start working. Once again, we still have to do IPNet outside and inside on the interfaces. But after we do that, we're good to go. How do we analyze it? Same exact show commands, and that's NAT. So now we're going to go to port forwarding. And if you're a gamer, you probably have heard of this. So port forwarding, what it's going to do is, even though we're natting, it's going to take a port and forward it to a certain other port. So a lot of times you port forward from the outside IP address to an inside IP address if you are, I don't know, playing Call of Duty or some game like that. It can improve your performance, or I don't know. Anyways, you do it so that the game protocols can reach your your client. So anyhow, another reason for this is it's very it's a good deal. We could actually have a web server on our inside network, right? If we had the outside, if we knew our outside IP network and we forwarded and we said, hey, port 80, go to this IP address. So what it is, it's linking an IP address with a port number. Down here, if you can see that, that's the IP address it's linking to, and it's saying send forward port 80 to port 80. Okay, now on it, that's where it could be used on a home network, is like I said, for gaming or for something like that, like a website. If you want some people to access it, just a word of caution, that's probably illegal. For most ISPs, you're not allowed, if you're doing anything other than just personal stuff. You've voided most policies. So check your license agreement with your ISP before you do any of this stuff. But port forwarding with an enterprise, it would be more common that what we do is we want to manage a certain device, and so instead of just leaving SSH ports open, we can actually say, hey, if you're trying to SSH to port, I don't know, 400, it actually will SSH to a certain device inside of our network, right? Because so our NAT's happening out here. These are our routers. Okay, and we'll say NAT's happening. Actually, it probably wouldn't be happening in routers. Probably have a router right here. And then, I don't know, this is our switch network, and there's a bunch of switches down there. So what I can do is I can set up port forwarding that I SSH to a certain port on this interface, and it actually takes me to this device. It just forwards that port straight to that device. So it's kind of like static NAT, but it's just with ports. So how do we program that? Well, back to our IP NAT inside source. And usually, I don't know, usually it's IP inside source static, then these TCPs or whatnot. And so what it's doing is it's similar to the static command, and we just say, you know, IPNet inside source stat and then static, right? Because we're statically setting this. This is not dynamic. That's why we say static. Then we pick the protocol, TCP or UDP, right? What port are we forwarding? So TCP or UDP. Then we put the IP address on the inside, right? Remember, just like when we did static NAT, just straight static NAT, inside we put 192.168.10.254, and then we pick the port of port 80, right? So it's going to forward to the local port, port 80, and then we have the outside port of 209, blah, 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 and 8080. So 8080 from the outside, out here, is going to forward to 80 at this device. And that's how we do it. Once again, we put in our IP inside, IP NAT outside on our interfaces, and that's port forwarding. Alright, so next, NAT for IP version 6, question mark. We'll say this is one way. Usually we'd probably tunnel, but I guess if we want to do this old NAT 6 to 4, we're going to, is that what it's saying? Yeah, I believe that's what it's saying, but that picture isn't what I'm looking for. Anyways, it's going to translate these private addresses, or these IP version 4 addresses, into IP version 6 going this way. Alright, so goes back to what is an IP version 6 address. Hopefully you understand it by now. We have a prefix assigned by our ISP or something like that, and then the global ID and our subnet ID, right? So if this part is all the same in a /64, then it's in the same network. Then this is just the host portion. So basically, all we have to remember is if this is all the same, then the host portion doesn't matter. It's just a host address. Okay, that's what it's saying. I don't know why we're talking about that so much. Okay, so NAT is translated into IP version 6. That's all that's saying. So IP version 6 hits the router. The inside's IP version 4. Or I guess some of this is not. I don't know. This is just a regular IP version 6 network. Apparently we're doing IP version 6 on the inside. And we translate to IP version 4 internet. IP version 6 internet doesn't have to be translated. Neat. So that's our 6 to 4. Because it's going 6 to 4. The NAT PT is the opposite, where it goes 4 to 6. But I'm confused, right? It said we're going to configure it. I'm not seeing any configuration commands issued anywhere. It's temporary strategy, blah blah. Anyways, so I guess that's just the theory of how to configure it for NAT. Troubleshooting NAT. Well, back to show commands. We've seen them already. Show IP NAT translations. What's our other one? We can clear the translations. We can debug the translations. You usually don't have to do that, or you're having a big problem. So usually your problem is you didn't do inside or outside, or you haven't allowed this network. I guess usually before I do anything, what I do is on my source list, I just do a permit any and see what happens. And there's times when it doesn't fire up, and so I usually even try reloading my router. Probably not the best idea if you're in a real environment, but in a lab environment or when you're starting it up, just testing something out. Hopefully you test it before you throw it in so you get it working, and so when it powers up it actually works. But since the commands are so limited, you're usually okay. You just want to check to make sure you're in the right networks of these interfaces, that kind of thing. Here's the debug command. We can debug anything, but if we debug IPNAT, this is one way, especially if it starts working really well, it bogs your router down, or could crash it. I've crashed routers debugging NAT, so make sure it's broken before you do this debug, because it just keeps doing commands like this. Good information is just the asterisk next to the NAT indicates the translation is occurring in fast switch path. First packet is the conversation is always process switched, which is slower. The remaining packets are fast switched. Okay, so that's the best information on that page. Anyways, I would definitely try these NATs, because NAT isn't that important for the CCN that you guys are going to take, but by CCNA exam there are a lot of NAT questions and sometimes a NAT lab, so make sure you have a strong understanding of NAT. But hey, look at the good, and look at another good point of this, CCNA2, last chapter. Looks like you guys are done. There's going to be a packet tracer assignment coming up that is a fairly long one, and I believe it has NAT in there and other things, so it'll be a lot of fun. If you have any questions, send me an email. Thank you.